In this video, we're going to be continuing what we learned last week from synthetic division and apply two theorems that are in your book called the factor and the remainder theorems. They both kind of lead to the same conclusion, so we're going to study those kind of and just morph them into one theorem. And that theorem looks like this. The factor/remainder theorems basically states that if we have some function we'll call f of x, and we divide that by some x minus c, where c is a constant. So like, let's say this is x minus 2, and we had some function f of x is 3x to the fourth minus 2x cubed plus x minus 10, right? Some function like that. And we divide it by x minus 2, let's say, and we get a remainder of 0. So I went through my synthetic division, I did that function divided by x minus 2, and I get a remainder of 0. Then x minus c is a factor of f of x, meaning if I were to factor it out, x minus 2 would be one of the factors, which also implies that c, that in this case 2, is a 0 of the function. So if I divide it out, I get 0 as a remainder. X minus 2 would be a factor of the function, which if we then would solve that, we would get a 0 of the function as well. So 2 would be a 0. And we're going to accomplish this theorem. We're going to apply this theorem using synthetic division. So we're going to take a look at the problems on Delta Math to explain this. If you're still a little fuzzy on what the theorem actually means, no worries. You'll get the hang of it. All right, so you're going to have a series of questions, multiple choice questions with this. Try your best to use synthetic division. Don't try to find a workaway around this, but do the synthetic division on all of these. So our first question, we're given this function f of x, and we're given an x minus c's. These are all series of x minus c's. We have to figure out which one is not a factor. So if we're trying to find out which is not a factor, translation is which one will have a remainder. Because if it has a remainder of 0, in other words, no remainder, then it would be a factor. So which of these would give us a remainder when we do synthetic division? Well, let's just start with the first one. Setting it up. First thing to double check is make sure the powers go in descending order. So we got 3, 2, 1, and 0, so we're good. So we do our little box. We have our coefficients 1, 7, negative 14, and negative 48. Draw our box. And with the first one, it's x minus 2. So remember, it's always the opposite that goes on the outside, so it'll be a positive 2. Bring the 1 down. 2 times 1 is 2. 7 plus 2 is 9. 2 times 9 is 18. Negative 14 plus 18 is 4. 2 times 4 is 8. Add those together and we get negative 40. Remember, this last one is the remainder. So it appears, well, actually the first one, we got lucky. That one has a remainder, so that one is not a factor. If we were to go through and do the rest, we would assume we'd get 0. Let's just try 1 just to verify here. Verify that I'm not crazy. We're going to use the same box, 1, 7, negative 14, negative 48. And let's do the x plus 8. So let's do negative 8, because remember, it's always the opposite. So bring down the 1, we get 1. Negative 8 times 1 is negative 8. Add those together, we get negative 1. Negative 8 times negative 1 is positive 8. Negative 14 plus 8 is negative 6. Negative 8 times negative 6 is positive 48. Add those, we do get 0. So that means this is a factor. This also means negative 8 is a 0. And this is not a factor. And presumably, if we were to do the other two, we would also get 0. They would be a factor, but no need to waste our time. All right, let's go ahead and try another one. Which one is not a factor? Let's do, here's some different ones. All right, yeah, which one is a factor? So let's ask the opposite question. Which is a factor? Which means we need a remainder equals 0 in one of them. Only one of them will give us a remainder of 0. So we got to figure out which one. Let's again start by just checking the powers. We got 3, 2, 1, 0. So we don't need any placeholder zeros in there. So we write this out. 1, -1, -10, -8. The number on the outside, let's just work our way down, would be a positive 2. Bring it down, we get 1. 2 times 1 is 2. Add those, we get 1. 2 times 1 is 2. Add those, we get -8. 2 times -8 is -16. So we get -24. So that one does have a remainder, so that means it's not a factor, which we're asked which one is a factor. So let's try the next one. X plus 1. Keep the box. 1, -1, -10, -8. This time on the outside, we're going to put a -1, because it was a positive 1. Bring the 1 down. -1 times -1 is -1. Add those, we get -2. We get positive 2. Add those, we get -8. Multiply those, we get positive 8. Add them, and we do get 0. So that's what we're looking for, which means this one is a factor. So go ahead and select that one. No need to check the other two. We would assume that they would not be factors. As long as you do it correctly, generally you don't have to do all of them. All right, let's go ahead and try one more here. At least. I think they all ask you either what is or is not. Yeah, it looks like that. All right, here we go. This is the other scenario. So in this one, we're given the x minus c, and we're supposed to determine which of these functions for the x minus c is it a factor. So this one, the box is going to change, but the number on the outside will stay the same. So this one, our c is -1, essentially. Because when you solve for it, it would be the opposite. All right, so let's just start with the first function and see which one it is a factor. Just double check. I believe all of these, it has every term, so you shouldn't need any placeholders. If you remember the last assignment, you had to put in placeholder zeros. I think all of these are just standard ones where there is no placeholders. So let's go ahead and start. 1, -12, 27, and 40. Outside is -1. Down the 1, -1, -13. You add those. Positive 13. Add those, we get 40. -1 times 40 is -40. Add those, and we get 0. Oh, that's great. So we got what we're looking for in the first shot. So that will be the answer. Let's go ahead and just verify by doing one other one. Just go ahead and do the next one for the extra practice. So for that one, 1, -14, 53, and -41. And then we do the same -1 on the outside. This time we should not get a remainder of 0. So bring it down. 1, -1. And those we get -15, positive 15, 68, -68, -109. So definitely not. And again, we would presume the other ones would be a no as well. All right, and let's just do maybe one more good measure. Just pay attention to the wording, whether it asks whether it is or is not. This one is, so we want a remainder equals 0. So if we write out our box, we got 1, 6, -9, -14. Start with our first one there. X plus 1, it means when -1 out there. 1, we get -1. Add those, we get 5, -5. Add those, -14. Multiply that, we get 14. And we do get 0. So we got lucky again. It happened to be the first one. I don't know if they designed it that way, but it seems like awfully a lot. Seems to be the second one. So that is going to be it. Remainder of 0 there. Again, we could confirm. Maybe let's just choose the bottom one on this one to confirm that that one should not be 0. So we get 1, 6, -9, -14. Put a positive 10 out there. 1, 10, 16. Oh man, that's big. 160, 151, and then multiply that by 10, 15, 10. Yeah, so that's a big number. Doesn't matter, it's not 0. And presumably, again, the other two, that would be the same. All right, so that's all there is to this assignment. Just going to be using your synthetic division to figure out if you get 0 as a remainder or not, and that will tell you whether it is a factor or is not a factor. As always, reach out to me if you need help. Thanks.